Hello there. In this video we're going to do a circle problem involving tangents. So we have this external point here P, and it's opening up to a circle and it's creating some points of tangency. So let's go in there and label stuff. It doesn't really matter what I label things, but the general convention is that we call the center of the circle O, and we're just going to call these A and B. Now, some things that we know is that these tangent lines are going to be perpendicular to the radius. So I can go and draw the radius, put tick marks on them because I know that it's both the same distance because it's a radius, and because this is a tangent line, that's going to be a 90-degree angle. Now I'll actually go in here too and connect this point out there externally to P. So you may recall that we proved a couple other things in class. You can probably see it in the observation that this length here, AP, that's going to be congruent to BP. This angle doesn't look like it, but this angle and this angle are congruent. This line's bisecting the big angle, and that one are also going to be congruent. But let's label what we know here. The circle's diameter is 14 centimeters. So each of the radius, that's going to have to be 7. That's 7, that's 7, and that one there, that's also going to be 7. Now the other thing in there is that the point P is 14 centimeters away from the circle. Now the only meaningful way to talk about that is that that's going to be this distance here. That's going to have to be 18. And that makes sense because it needs to be a shortest distance, like 18 centimeters away. Well, that could be 18, but then this would be shorter, so why wouldn't we measure it to there? And that's going to be that closest point. So that's going to be the 18. Now we're trying to figure out the angle. So I'm going to label this part of the angle here theta, and now we got to figure out what trig ratio, because we do have a right triangle, because of this there. What trig ratio is going to get us that theta. And we see that theta opens up to the 7, so that's opposite, and the 90 is going to open up to what winds up being this whole side here. So that's opposite and hypotenuse, that's going to be a sine ratio. The hypotenuse in this case is 25 because that's the 7 plus the 18. And we could actually do Pythagorean theorem here that 25 squared is equal to 7 squared plus whatever AP squared is, and eventually get that AP is 24. So we actually could set up other trig ratios too. So I'm going to just put those over there. Now, you can take any one of these. Let's do the sine. So theta itself is going to be the inverse sine of 7/25. Make sure we're set to degrees, and we get 16.26. And I could double check with these over here too. All right, I just typed those in my calculator, is all the same thing. Now you do need to be a little bit cautious. We'll talk about this more in the future. Is this really the angle that we're getting when we do the inverse sine there? But because it's a right triangle, this has to be an acute angle, so this is going to be the one. There's actually another angle that produces the same sine ratio, but it would be larger than 90 degrees, and we know that this can't be. Okay, so now we want the angle at P opening up to the circle. That's that big angle, APB, but we know that the line OP bisects this big angle, so measure of angle APB itself has to equal twice theta. And we get 32.52 degrees right over here. Alright, so for a bunch of these tangent problems, remember that the radius, that's the same wherever you are in the circle. These tangent lines produce 90-degree angles, and then you can chop the shapes up into right triangles and use your right triangle trig ratios. Thanks for watching. Character and Scholarship for Life.